For our capstone, we decided to combine biking, which is something we're very passionate about, and Bluetooth, which is a very applicable tool that we were both interested in. We wanted to improve quality and eliminate clutter and maintenance on a bike, and thought Bluetooth was the perfect way to do this.
Shifting, which is what the derailleur does, is the part of the bike that moves the chain right and left and shifts the gears to accommodate different terrain. Most bikes use cable tension to pull the derailleur back and forth, but we wanted to eliminate cables and make the shifter stronger and more efficient.
For our system, there are two Bluetooth chips, a sender and a receiver. These Bluetooth chips talk to each other, sending simple signals such as degrees the motor needs to turn. As a final product, we used a dial that sent signals to the sender chip, which corresponded to the rotation of the motor. The final step is the client receiving the information from the server and telling the motor how to move, creating our final circuit.
Finally, as our motor moves, it is attached to three joints that look like the letter Y. The ends of the Y are connected to two corners of the derailleur, which as we push the bottom of the Y up and down, the sides extend and contract. This rotates the derailleur back and forth, completing our system.
For this project, we split it up into weekly deadlines. For the first week, we focused on the physical design, taking precise measurements, 3D modeling, and printing exact pieces to fit our model. For the second week, we focused on coding the Bluetooth chips to send simple signals. This required us to learn new coding functions and fundamentals, as well as understand the basics of how Bluetooth and similar systems work. Finally, in the third week, we applied it all together and took this time to troubleshoot any further issues, modify, and adjust the final system.
The skills we learned would be very useful in machine interface situations as well as early prototype engineering jobs. For example, we based our project off a real product that went through many iterations. This way of prototyping and testing and these specific skills would be perfect for this type of job.
In the future, knowing what problems we ran into would obviously have helped, but we couldn't plan for these. To improve our system, some things we could have done differently were making the whole system a lot more compact and easier to put on a bike, design and 3D print a hold for the controller, and calibrating the system to work on a 12-speed gear system.
With the amount of time we had and the limited resources, we were very happy with the product we made. For the most part, we didn't run into any big problems, and we were efficient with the time we had. In the future, if we had more time, we would like to put our product on a bike and use buttons as an input instead. Building off of this, in the future, we could also use these concepts to create more helpful systems to improve the quality of life for people and start larger scale products.